Hey everybody, last formalizing section of Unit 6 here. We're talking about powers of a test. Notes and everything are down below. If you want to see the previous video that all this is based on, you can do that. Or if you're just here to summarize it, thanks for joining us. Obviously, if you like what you see, hit a subscribe button, hit a like, and all that other good stuff. So power. Couple of things here. So remember, this is the box about types of errors from last time. Just like last time, we have the null hypothesis is true. We have all the truth across the top. Null hypothesis is true. And we have that the alternative hypothesis is true. So the first one is everything is normal. The second one is that what we're looking for actually is happening. Then there's the two things that can happen with our test. We either reject the null hypothesis or we fail to reject the null hypothesis. Now again, remember, so if we fail to reject the null hypothesis, that means that we're assuming that it's going to stay true, and that if it's in the true column, that's a good thing. Okay. Likewise, if we reject the null hypothesis and the alternative hypothesis is true, that is also a good thing. That is going to be where the power lives. Okay, so that is also a good thing. And the power is going to tell us what the percentage of chances that we're going to have, or what's the probability of that happening, okay, which is the whole reason why we do the power. The type 1 error here we set when we do the significance test. That's our alpha value. So again, remember that's this. Actually, I have it down here. And then for the type 2 error, that's going to be because remember, these two things have to, if we're talking percentages, these two parts have to add up to be 100%. So the type 2 error would be 1 minus your power. And so that's how you actually calculate out what the percentage is, or what the probability is of that type of error happening. So alpha we set. Type 1 error, the probability of a type 1 error is alpha. The probability of a type 2 error is going to be 1 minus your power. Okay. You know what? You guys are worth more than that. Let me just totally fix that. There we go. Anyway. Now, in terms of interpreting the power, this is how you're going to say it. Okay. So, power, remember, is the probability that we reject the null hypothesis given the fact that the alternative hypothesis is true. Okay, so we have evidence to say that what the assumption is wrong, and the assumption in fact is wrong. Okay, so the alternative hypothesis is true at a specific value in context. So you're going to spell out what the alternative hypothesis is. So if the alternative hypothesis is indeed bigger than 20%, using the example that we did before. Okay, there is a power probability. So this is the power value here of finding convincing evidence to reject the null hypothesis. And again, good idea to put some context into it. All right. Now remember, to increase the power, you can do one of three things. You can increase your sample size. You can increase your alpha value. And as I said, that's somewhat problematic because the alpha value will change. You might be rejecting something that's not happening, that is happening. And then the other thing that you can do is that you can increase the distance to your alternative hypothesis. So the distance between, if this is the population value for my null hypothesis, the further I can get that away, the further I can get that and what our data is saying is apart, the better off we're going to be. The best one in my mind, obviously, is increasing your sample size. Because if you're increasing your alpha value, while it is helping your power be better, that is all given if the alternative hypothesis is true. If the null hypothesis is true, then you're going to be getting this type of error here. All right. So anyway, let's talk about this. So here's your example. There's a stats major and a finance major who decide to get married. In order to investigate their per-person expenses, they select a random sample of guests who are invited to the wedding and records whether or not each person plans to attend. Because what else is a financial analyst and a stats major going to do? So they decide to test the null hypothesis that 75% of the people are indeed coming. The alternative hypothesis is that 75% of the people are not coming, or the people who are attending, it's different than 75%. I'm sorry for misspeaking. Where P is the true proportion of all guests that will attend the wedding. Okay. So then there are 4 parts. The first one being here, and I'll let you pause this here in a second, but the power of the test is to reject, the power of the test to reject the null hypothesis, p is equal to 0.75, when, let's say the p-value is actually 0.70, using an alpha value of 5% and a sample size of 25%, is 0.10. So interpret what that value means. And I'll go ahead and pause, write it out. We'll see where you are here in a second. All right, so it says something like this. And basically, it's what we have up here. We're just putting the context into it. So if the proportion of guests that will attend the wedding is 0.70. Okay, so again, there it is, my context, my alternative context in context, my alternative hypothesis in context. That's what I'm saying. There is a 0.10 probability that the couple will find convincing evidence to reject the null hypothesis, which is the proportion of guests attending the wedding is 75%. Okay, so they only have a 10%. So if 70% people are really coming and they're thinking it's 75%, there's only a 10% chance that they can find evidence that will happen. All right. Question number 2, find the probability of a type 1 error and the probability of a type 2 error for what's going on up here in 1. Well, type 1 error we love. Why? Because there we go. It's 5%. It's the alpha value. They tell us that. It's awesome. It's great. You just have to remember that it's there. For the probability of a type 2 error, remember it's going to be 1 minus the power. So in this case here, our power was 10%. So 1 minus 0.1 is 90%. So we have a 90% error saying that. So again, remember what type 2 says. So it's 90% chance that if there's an error, that if HA is true, that we're going to be failed to reject it based upon what we're currently seeing. Determine whether each of the following changes would increase or decrease the power of the test and explain your answers. So the first one is going to be you use an alpha value of 1% instead of 5%. Now remember what we set up here. To increase your power, you actually have to have your alpha value go up. So this is going down. So we would say, well, power would decrease because when the alpha level is decreased, it makes it harder to reject the null hypothesis. If it's harder to reject the null hypothesis, remember up here, power is the probability that we get to reject the null hypothesis. That's going to drive it down. All right. What happens if we use an n value if they do a sample of 100 instead of a sample of 25? Now, for some people, that would be everybody who's coming to the wedding. And these days, probably 25 is still more than what you should be having. But anyway, so power, if I changed to 100 from 25, the power would increase because the sample size increased. Okay, great. I did want to say one more thing about this. Why is that? Okay, because remember, when n goes up, my standard deviation goes down. When my standard deviation goes down, that will take my z-score higher. Okay. When your z-score goes higher, your p-value goes down. Okay, and so that's the reason why the power would go up. You're going to make it more likely to be able to reject stuff because that's what's going on there. So anyway, as I said, this is one of those kind of niche areas. It's important. This is going on. But I've found that students who really get this tend to be able to just latch on. They come back to me after the AP exam. They're like, Mr. Hayes, there was this question about power, and I got it, and da-da-da, and they get all excited. And every multiple choice question or context question you can pick up is more points for you, right? Closer to passing. So anyway, hope that was helpful. I will see you over in Unit 7. As I said before, we're going to do confidence intervals and significance tests again, but we're going to do it with means instead of just doing it on proportions, okay? So hopefully you'll have a better time, and not should say better time. It should be a little bit more relatable because we know how all the ins and outs of what confidence intervals do and what tests will do. We're just going to have to figure out how do we do it in this context. So anyway, look forward to seeing you over there. Talk to you soon.